Hi there. So for today's video, I'm gonna prove the two proposition which is called the Morgan's laws. Okay. So these are the proposition that we are gonna solve on your screen. Okay. So in order to do that, let's say that for any three sets, A, B, and C, we have A. Set A is not and B union C is equal to A is not and B, or set A is not and B, intersection set A is not and C also. Now let's have the second one. A is set A is not and B intersection C, which is also equal to A is not and B union A is not and C. Okay, but let's have first the first one. Okay, so we must prove it. So in order to solve it, let X be an arbitrary element. Yeah, let's have that. So let's say that X is an element of A, but not in set B union C. Okay, and let's prove if they have the same thing. Okay, so in the other side, let's say that X is an element of A, and X is not an element of B union C. In other words, X is an element of A. As we all know, negation makes not also negation of X element of B or X element of C, of C or element of C. There you go. Okay, now let's proceed in the next step. In other words, X is an element of A and X is not an element of B and X is not an element of C, not an element. Okay, let's continue the process. Distributivity, of course, we need to distribute. Let's have this thing first to this one. Okay, so we have X is an element of A and X is not an element of B. That's it. Now let's have the other one. This thing to this. So we have X is an element of A and X is not an element of C. Okay, now let's have the let's simplify that. So same as this thing. Same with this. X is an element of A, but not in B. And X is an element of A, but not in C. Can you see it? They are the same thing. Okay, so let's factor out the, as you can see, as you notice, they have the same variable, which is the x. X is an element of A. Okay, now let's factor it out. Let's factor it out. So we have a first one. We have X is an element of A, but not and B intersection A, but not and C. Therefore, 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 with that in mind, we can say that X is in A, but and and not in B, and X is in A and not in set C. Okay, that's it. That's the first one. Now let's have the second proposition under the Morgan's law. Okay. Again, we need to let X be an arbitrary element. So let's do it now. Let's have it. So X is an element of A, but not in B intersection C. And the other side, X is an element of A. X is an element of A, and X is not an element of B intersection C. All right. Next step is X is an element of A, and since we all know that the negation is, okay, I forgot to put that here. It's not an element of B intersection C. Negation is the same thing with not an element, so let's have the negation. And negation now, X is an element of B, or X is an element of C. All right, there you go. Now let's simplify it more, or that is the same thing as X is an element of A, and X is not an element, not of B, and and or rather, or X is not an element of C. Okay, so as you can see, the negation became not out, not out. That's how it goes. All right. Of course, the next step is the distributivity. Just distribute the X is an element of A in the parentheses. Okay, so let's have that now. So first is this to this. Let's have that now. So let's have it now. X is an element of A, and X is an element. It's not an element of B. All right, now let's do the other. Okay, let's have the orange one. Here you go. So this thing and this. And or rather, or x is an element of A and x is an element of C. It's not an element of C. Alright. Same, so as we write it down, it is the same thing as it is, as this. X is an element of A, but not in B, or O, or X is an element of A, but not in C. Alright, but not in C. With that in mind, we can say that X is an element of A, but not in B, because we factor out the X as an element of X, because we factor out again. So as you can see on this top, we have the same variables in both sides. Here, the X. Okay, so let's now factor it out here. Did you get it now? So we have union, oh, union A, but not in set C. Okay, so let me rewrite it for you so you can see it properly. So that will become X is an element of set A, but not in B, union A, set A, but not in C. There you have it, ladies and gentlemen. That's it. All right. Okay. This is the result, and we got it right. Okay. Therefore, in conclusion, we can say that therefore therefore X is in A and not in B, or X is in A and not in C. Okay, so as you notice, I capitalize the or here, or, and the other one I capitalize the, and so that is the big difference between the the Morgan's laws. Okay, and I hope you understand it very well. Thank you for watching and listening. Goodbye.